Your RAG may already be broken, and the worst part, most RAG systems fail long before the query even arrives. What could be the reason? And reason is poor chunking. Welcome to NeuraArch AI Architecture series, and today we will have a deep dive in the chunking, the backbone of the RAG ecosystem. So let's start with chunking. So chunking is always remains the most underestimated, undervalued task from the developers or architecture's perspective. Everybody concentrate about to improve the embeddings or choosing a right model, but when we pay a less attention to a chunking, the backbone start failing. So let's have a deep dive in a chunking. So what is exactly the chunking? The chunking is dividing the large document in a different parts. That is called chunks. The standard meaning of the chunk. But how this chunking has to be carried out, and that is what we are going to look into this architecture. Chunking strategies and the organizations of those chunks. In the last lecture, we have overlooked a RAG ecosystem where we talked a little bit about chunking, what exactly it plays the role in the RAG ecosystem. So just to remind it, this is the overflow or the RAG pipeline, and you can see just the first step is a chunking, where you are converting the large document into smaller parts. If anybody wants to have the broader knowledge of the RAG ecosystem, please feel free to visit the previous lecture about the RAG ecosystem. So now what we know what chunking means, right? Now how to define the strategies, how we should segment the large document in chunks. So there are different types of strategies: fixed chunking, recursive chunking, markdown chunking, semantic chunking, agentic chunking. So these are different types, the way we can achieve a chunking. Okay, we will go through each type one by one. So first we will take fixed length chunking. This is pretty standard, pretty easy. The large document will be divided in different chunks based on the fixed number of tokens. So for example, we just take the 500 tokens. Okay, and if you have a document of 10 pages, the chunks will be separated by after every 500 tokens. That is what the fixed length chunking. So you can see an example how it could divide the document based on the number of tokens and what problem can cause. So definitely, if the tokens are completed and if your statement is still not completed, it will divide the statement in between. So your statement may get split in two different chunks. So that could be the problem with the fixed length chunking. So when to use it, when not to use it, we will discuss that. We will have the collaborative or the overview of all the chunking strategies at the end. But just right now I am telling the pros and cons of each chunking strategy. Okay. So we covered the fixed length chunking. Now the recursive chunking. So this is the next step, or more intelligent I would say, than the fixed length chunking. In the fixed length, as you see, it was based on the 500 tokens. But in the recursive chunking, it is not based on the token. it is based on the hierarchical separators. For example, paragraph, sentence, or words. So when we give any sentence and create a new line, there are some symbols getting inheritedly created, right? Slash n for new line, slash n for paragraph, full stop or dot is for completing the sentence. So these are the things where actually the chunking is going to get decided. So that is why we can make sure that your sentence will not get cut in between the chunking. So for example, this is the original text. Hypertension treatment includes lifestyle changes. Patients should reduce sodium intake. Now if we applied a recursive chunking over here, then assume it will separate out with these two chunks. So first sentence like hypertension treatment includes lifestyle changes, patient should reduce sodium intake could be one chunk, and the second chunk could be regular monitoring is important, like this one. So this is how actually the recursive chunking works. Whatever was the disadvantage in the previous strategy of the fixed length chunking, we try to overcome here in the recursive chunking. The third strategy is more intelligent than that, the markdown or structure based chunking. So if we have a document with the proper headings, the way which we give, if that is the nature of the document, then the markdown strategy can be easily applied. How actually it works? It works on the headings. So based on the headings, the documents will get split. It will not be based on the full stop or new lines. It will be based on the headings. So sometimes it could be the thing, your heading may be much more larger, like it can take 2 pages. If the document is designed in that way, then your chunk may be created for entire 2 pages. And if sometimes you have just 1 or 2 lines under specific heading, then it could be the very small chunk you will be getting out of it. So this can happen with the markdown. So this is the third type of the markdown or structure based chunking. We will see when this is very useful, the scenarios of where the markdown structure is going to be used. Let's move to the fourth, that is the semantic chunking. So semantic chunking is based on the meaning of it. Okay, it splits text between based on the meaning rather than the length, rather than the headings, rather than your new line or paragraph. It identifies the meaning, and based on the meaning it will split and create the chunking. So for example, hypertension is a condition characterized by high blood pressure. Treatment options include medications and lifestyle modifications, such as recalling salt and make exercise regularly. So now here we can get different semantic. One is the definition of hypertension, then other semantic meaning what treatment has to be applied for reducing the hypertension, and then third chunk would be what could be the disorders can be created because of hypertension. So these are different meanings that can come out, and the semantic chunk will be created based on the meaning of it. So it is good for a better retrieval, but ultimately This is more intelligent than what we have saw 3 strategies so far. This is more intelligent than that. The final one would be agentic chunking. Now, this is the most intelligent chunking strategy. It uses LLM to decide the chunk boundaries. So rather, we are defining the meaning of it within a document. The LLM will define the boundaries, and LLM will decide the semantic meaning and where to cut the chunks. So no manual efforts, fully reliable will be relying on the LLM, and the expected output is going to be definitely high. But one thing to remind, it will slow down your chunking because LLM will take some time to analyze the entire documents, because when you are doing the live projects or big projects, the documents will not be smaller, right? It would be having the ample of space, right? So that is why it would be slower, because LLM has to process each and every document. They need to convert it into tokens. So now when it comes to a token, you just need to recall it. It is a fuel, and that is why the agentic chunking is going to be an expensive one, because how much bigger your document, those will impact, or those will feed the more number of tokens, and obviously the output will be again the same number of tokens. So it is going to cost you much rather than the other strategies, but definitely it is going to be useful. So now we have understood the different strategies of chunking. We understood about fixed length chunking. We understood recursive chunking, markdown chunking, semantic chunking, and agentic chunking. So now we will have a comparative study, and we will see the advantages and the limitations and the use cases where we can apply that thing. So in fixed length chunking, it is the simple, very easy, and it is inexpensive, easily understandable. So it is best in times when we want to develop a quick prototype, because the limitation, it can break the sentence or ideas in between. So it is very risky to use it in actual industrial or enterprise level applications, but for quick prototypes, yes, definitely we can use it. In recursive chunking, it will preserve the structure. It will better than the fixed length chunking, but it is not based on the semantic. We can use it in the smaller applications easily, and it can be the strategy which can be chosen for the production ready software as well. But I would not recommend it to use in the large scale application. We can use it in the RAG systems, but not for the large scale applications. The third, the markdown structure. So markdowns, where we are giving the headings properly, and the divisions are going to get, or chunks are going to get created based on the headings. The markdown strategy is good, and especially it will work for the documents which are pretty much defined in a proper manners, or the Git repos where we already expect some markdowns noted over there. So such kind of the documents are good to be chunked using the markdown structure. Even the manuals is the best example, where always things are going to get segregated with the proper headings. So the markdown structure is good for that. So in short, the RAG may have different types of knowledge base, but each knowledge base can be chunked using the different chunking techniques. It is not that you always have to follow the one single chunking technique. Okay. We will come about the semantic chunking. So it will have the better boundaries and it will give you the better retrieval. So it is always good to get implemented on the knowledge basis where you are actually having the knowledge base. For example, the WHO guidelines where you are using the knowledge base, or maybe some legal jurisdictions documents where you can use this semantic chunking pretty effectively. But from the computational perspective, this is going to be an expensive. And the last one which we saw, the agentic chunking, is the dawn of all the chunking, I would say, but it is going to be the costly. It will give the accuracy very good, but you have to always bear in the mind the cost factor of it. And you might have observed, like, the intelligence is getting increased day by day the way we are moving from the fixed length chunking towards the agentic chunking. The intelligence is getting more and more accurate over there. So one of the things that we need to consider is the chunking strategy determines the retrieval quality. The reason I am saying, if you remember from the context from the last lecture, whenever you fire a query, the query doesn't go through the full document. It finds the similarity based on the chunks. So the how good chunking strategy or quality that you are giving, you will get the accurate result. So that is why we started with the lecture how the poor chunking will cause to fail RAG systems even before the query reaches to the document. If you have the wrong chunking strategy, your output is not going to be as good as you expect. So that is why choosing a strategy for a chunking always defines your retrieval quality. So anyone can say, if agentic chunking sounds powerful, then why shouldn't I use it? But always powerful means not useful all the time. That is why we need to understand when agentic chunking makes sense, because it comes with the high cost. If you have documents like legal contracts or medical research papers or policy documents, long reports, then definitely for such a complex documents or for a complex knowledge base, you can go for a agentic chunking, because in such documents concept boundaries are not clear, right? And that is why LLM can detect semantic meaning better, and they can do the transition of those semantic meanings with specific boundaries in better chunking. That is why if you have a document very complex, definitely you should go for agentic chunking. If the documents are semi-structured, semi-structured means the documents like Word articles, blog posts, reports, or mixed formatted documents, then you can go for recursive chunking, or you can go for token based chunking. But as we discussed, token based, I mean the fixed length, but for the prototype. But otherwise you can go for a recursive chunking, because the paragraph, sentence, new line, full stops are handled properly. If the documents like GitHub repository where the all headings are accurate, these kind of such technical documents or markdown documents, the company manuals, such kind of documents are perfectly suitable for the highly structured, for the markdown chunking. So that is why I was saying, like, it is not necessary that you have to use a single strategy, because RAG is going to be your knowledge base. It will have different types of documents that you are going to feed to RAG, and based on the different types of documents you can choose the strategy. The smarter the document structure, the simpler your chunking strategy can be, and that is the thumb rule for chunking. If you make a document better, you will be using that better while defining your chunking strategy. RAG systems don't fail because documents are missing. They fail because context gets broken between chunks. And the solution for is the right organization strategy about the chunks. That is chunk overlapping. So we have seen the strategies about how to do chunking. Now we will look for the organization strategy. Chunk overlap, hierarchical chunking, and metadata based chunking. These are pretty standard chunking organization categories. We'll go through one by one. First, understand the chunk overlap, what exactly it means. So if you observe these chunks, the hypertension treatment includes lifestyle changes. Patient should reduce sodium intake. This is a chunk 1. And if you observe, patients should reduce sodium intake. ACE inhibits are commonly prescribed. So if you observe this line, patients should reduce sodium intake, is common between the two chunks. That is the overlap what we are talking about. Now, why this overlap matters? It matters to keep the same context between the two chunks. If you have entirely different context for the two chunks, but they are actually having the same semantic meaning, then your query may go wrong, because as we seen in the previous lecture, query always calculate over the chunk. It is not calculated with the chunk together. We have seen the strategy for that, recalculating the score, but for the precautionary, keeping the context same between the chunks is always a good. And that is why overlapping of chunk is very important. This is again the example of the shared overlap between the chunks. Now, the second organization strategy is hierarchical chunking. So, organizing the chunks by drilling down the document. So, the document will have different sections, different paragraphs, and as we drilling down the documents, we will start creating the chunks. That is called as hierarchical chunking. So, few of you might get confused with the markdown strategy what we have seen so far. It based on the documentation strategy, headings and all that stuff, right? If you /n and then maybe new line or new paragraph, that is for markdown. Then other one was based on the proper heading, right? So that could be the different strategies, you may get confused with the hierarchical chunking. But those were the strategies, and this is an organization way of chunks. So that means you can have hierarchical chunking getting fit for the Markdown chunking, Semantic chunking, and Agentic chunking. You can implement hierarchical chunking in all these kind of 3 strategies. They fit it for very well. Even for recursive splitting, it is possible up to certain level. But in the fixed length chunking, you cannot use hierarchical organization of the chunks. It only suits for Markdown, Semantic chunking, and Agentic chunking, and up to certain level for recursive. Okay. Now, the third organization part with the chunking is metadata with chunks. So whenever you are splitting a document in the chunks, it is always advisable to set the metadata context. So it can explain what exactly chunk is talking about. You may have specific categories, you may have specific IDs for them, or maybe the internal details of the chunks can be categorized it separately and added as a metadata, because it helps you for the retrieval. In the previous lecture, we saw how metadata helps us to filter the things. If you remember an example of the asthma treatment where we talked about asthma, the query was about the right treatment and we retrieve the symptoms of asthma. That is because of not filtering the chunks properly. Or other example realistic could be, if you are finding the right treatment for asthma for adult person and you are retrieving the treatment of the child or infant, because we cannot filter it based on the metadata. So for better understanding, please do visit our previous RAG ecosystem lecture. I'll add the link of that lecture in the comments section as well. But as we were having a deep dive, it was worth mention to metadata based chunking organization over here. It adds the traceability. It helps while ranking the chunks perfectly. And the important point of the chunk is always the sizing of the chunks. If you applying these strategies or organization strategies, but if you decide the chunk size is too small, it is going to hamper negatively because it will going to lose the context. If you start creating too large, again that would be a problematic because it will have to process the large number of tokens, and that is why it is inefficient and it is costly. It will not have the context properly because it may get confused between two different contexts coming together in the same chunk. So hard retrieval. If you go it for too small, it would be too short memory. So ideally in the industry, the chunking range is considered good between 300 to 800 tokens. That is the ideal balance. So this is what we talked about, the chunking strategy, how to organize it, how the actual tokens, or how we can keep the balanced token number of tokens inside a chunks. But designing a chunking strategy is a one thing, but how do you prove that it actually works for you? So stay tuned with us for the next video of this lecture series, evaluating chunking strategies.